At first glance, this looks like a simple projectile problem. A grasshopper jumps, the box is tilted, and we have to find an angle. But there's a hidden idea in this problem that many JEE advanced students miss. In fact, if you try solving it using the usual projectile equations, you'll end up using a lot of unnecessary maths. Today, I'll show you a 1 minute observation that reduces the entire problem to just one equation. A grasshopper on the bottom of a cubical box has to jump out of the box. If each side of the box is h, which is given as 52 centimeter, and the grasshopper can jump with a maximum initial velocity u, that is 3 meter per second, what should be the minimum tilt angle theta of the box so that the grasshopper can jump out of the box, and acceleration is given as 10 meter per second square. So there is a grasshopper inside a box. This is open from above, and this grasshopper wants to jump out of the box, and jumping speed is given as 3 meter per second. The minimum value of this theta is to be found so that grasshopper can jump out of the box. Let's see how to tackle this. So I've drawn this cubical box. It's open from above. This blue point is showing the initial position of grasshopper. It can be anywhere on this bottom surface. So I've just assumed it to be at this point, and let this point be A. And also we have taken this as x-axis, and this direction as y-axis. And the grasshopper has to jump in such a way that it just clears this point. It has to clear like this. It has to jump like this, and it has to clear this point D. So just clear this point D. The grasshopper's velocity should be parallel to y direction at this point D. Being parallel to y direction means Vx is 0 at this point D. And if we project this point D on this x-axis, it will be at the point B. So consider only the x projection of this motion. So suppose its velocity in x direction is ux initially, and at B, since it's moving parallel to y direction, its velocity in x direction will be 0, so Vx will be 0. And this is the direction of gravity, vertically downwards. And if we take its component along x and y directions, this angle is theta, suppose. It's given as theta, so this angle will also be theta, this one. And the component of gravity will be g cos theta along minus x-axis, in fact, and it will have a component g sine theta along y-axis. Okay, so now we are going to use equation of motion between A and B along x-axis, and it's since at B Vx is 0, so we are applying third equation. So Vx square is equal to ux square plus 2as. So acceleration is minus g cos theta, being opposite to x direction, and displacement is h because the side is given as h. So this displacement along AB is h, and from here we get the value of cos theta. Now we have to find minimum theta for this to happen, and from the expression we can easily see theta is minimum and cos theta is maximum. So cos theta to be maximum, ux should be maximum. And what maximum value of ux can this grasshopper have? It can have its full velocity as ux if it jumps in x direction itself. Then ux maximum will be equal to u, the full velocity, and therefore cos theta minimum will be in place of ux I have just written u, so it is u square by 2gh, and here from here we get theta minimum, cos inverse of this. Okay, so this is the answer we were seeking. Though it's not asked, but if we want to find this position from where this grasshopper should jump to make this attempt, for that we need some extra calculation. So applying this equation, v is equal to u plus at again in x direction, we'll get the time in what time grasshopper will move from A to D. So this is the time from A to D, and in this time what distance it moves along y direction. Suppose this point is C, So the distance moved along a y direction is AC. So AC is equal to ut plus half at square. Since our insect is having its full velocities in x direction, as we have just seen here, its velocity component in y direction will be zero, initial velocity component. So this is displacement. AC is displacement. So ut becomes zero. The u in y direction is zero. Half at square. So acceleration in y direction is g sine theta, the component of g along y direction. And time we have already found. So just put the value of time here and square it. So this is the value of AC. So the grasshopper from this distance AC, it has to jump to make this attempt. Okay, thank you.